In this video we're going to continue our exploration of collections, and in particular we're going to introduce ways of processing the objects that are stored within a collection, and that's going to focus on an introduction of Java's for each loop. We've seen that a collection stores multiple objects, and it's often the case that we wish to work our way through that collection, and for each object we want to carry out some form of processing. Programming languages often provide several ways of performing that processing, and the means for doing that involves using something called a loop. And the idea of repetitive processing is known as iteration. Some examples of iteration might be, for instance, that we wish to list out all of the tracks that are stored in our music organizer. If we've got a collection of students, then we might want to list all the students who are taking a particular course. We might want to do some selective processing on our collection of audio tracks. We might want to list out all those tracks by a particular artist that we happen to be interested in. Now, Java provides several different types of loop: a while loop, a do loop, a for loop, and a variation on the for loop called the for each loop. So, fundamentals of iteration are that iteration involves the process of repeating some actions over and over again. And those different types of loop provide us with different ways to control how many times we repeat those actions. So we'll often make use of iteration in a completely different context from processing a collection. Sometimes we simply want to carry out some actions some number of times and there's no collection actually involved. Now, with a collection, we quite often want to process every item in the collection exactly once. And there's a particular type of loop that we're going to introduce now, which is specifically designed for that idea of processing a whole collection and processing each item in the collection just once in the order in which it's stored in the collection. And this is Java's for each loop. Now, one of the reasons that we're introducing the for each loop initially is that it's probably the easiest kind of loop to understand. However, something that it's important to bear in mind as you develop your learning and develop your understanding of other types of loop in Java is that it's actually the least flexible of Java's loops, and that's probably what makes it the easiest to understand. And so, because we'll be introducing other types of loop later on, it will be important that you don't come to rely too heavily on using a for each loop in every situation simply because that's the first kind of loop that you've been introduced to. You need to understand how to use a for each loop, but you also need to understand its limitations as well, and there are several that we will point out in this video. So what does a for each loop look like? In the upper section of this slide, we've got the basic Java syntax elements for a for each loop. A for each loop is introduced by the keyword for, and that for is immediately followed by what we call the loop header. The loop header is enclosed between a pair of parentheses, and the loop header contains four separate items. Firstly, there's a type name. Secondly, there's a variable name. Thirdly, there's a colon symbol. And fourthly, there's another variable name where that final variable name is the name of the collection that we wish to process using this for each loop. In other words, it's the name of the collection that we wish to iterate over. The loop header is followed by a loop body, typically enclosed between a pair of curly brackets, which we know is called a block. And inside that block we can have as many actions as we wish. Those are the actions that are to be repeated every time we go around this loop. So the idea is that the body of the loop is repeated over and over again once for each separate element inside the collection. And so the lower half of the slide characterizes the way in which a for each loop actually operates. We can read this for each loop as meaning using each element in collection in list order, do the things in the loop body with that element. And that loop body will be executed exactly the number of times that there are elements in the collection that's named in the loop's header. So if the collection has 10 elements, then the statements in the loop's body will be executed exactly 10 times. If we have 50 elements in the collection, the loop's body will be executed exactly 50 times. And that's an important characteristic of the for each loop. Here's a concrete example of a real for each loop now within the context of the Music Organizer project. The list all files method is designed to iterate over the collection, so the array list files that contains all the file names of the tracks that the array list is currently storing, and each time around that loop one of the file names is printed out. So starting with the first file name in the array list, that's printed out, then the second one, then the third one, then the fourth one, and so on, so that each file name in the list is printed out in order. So using each file name in files in list order, we print the file name. Let's have a look at another example. Suppose a business organization wants to know the time of day in various cities around the world, and they have an array list of clock display objects, one clock display object for each city that they're interested in. As time passes, we want to ask each of those clock display objects to tick on to the next minute. And that's a process we'll want to repeat over and over again throughout the course of a day. But each time it's time for one clock in the list to tick on, we want every single clock in the list to tick on. So the update clocks method iterates over the clocks array list, and for every single clock display object in that collection, we ask it to tick on. So this method updates every single clock by one time tick each time the update clocks method is called. So we can characterize that as being for each city in clocks in list order, call time tick. Now we don't necessarily need to do the same thing to every single item in a collection. While the for each loop guarantees to visit every single object in the collection, we can be selective about what we then ask that particular object to do, or what information we ask that object to provide. For instance, here's an example of a method where we are only interested in printing a subset of the file names that are in our Music Organizer's array list. We're only interested in seeing listed out those file names that contain a particular string that we pass in as a parameter to the find files method. And so now inside the loop body, as we examine each individual file name within the list, we check to see whether the name of the file contains the search string of interest. And only if it does, so only if the call to the contains method on a particular file name string, do we then go and print out the particular file name of interest. So just note that the contains method that we're calling on the string file name gives a partial match of the file name. If we wanted an exact match, in other words, if we wanted the whole of the file name to match the whole of the parameter that's passed into the method, then we would call the equals method rather than the contains method. So those are two important methods defined in the string class, one of which gives a full match, which is the equals method, and one of which gives a partial match, which is the contains method. So loop statements allow a block of statements to be repeated, and the for each loop in particular allows iteration over a whole collection. Now with a for each loop, every single object in the collection is made available exactly once in the loop body. Let's look at a specific example of this in the context of the Music Organizer project. This is version 3 of the Music Organizer project, and it's been enhanced with an additional class which is actually able to play the tracks that we've stored inside our array list. If we look at the source code of the Music Organizer class, we can see the familiar array list field called files, the addition of a field to store a reference to a music player object, and then creation of that object inside the constructor. But the particular method of interest within the context of this discussion is the list all files method. So here's exactly the code that we've seen on the slide, where for every file name stored in the files collection, we want to print that out. And we can demonstrate how that might work. I've got a Music Organizer object down here. I can call the getNumberOfFiles method and it returns 4 to show that we've got 4 files stored within it. And we can call the listAllFiles method in order to see a printout of the various tracks that we've got stored within the Music Organizer. And these are all tracks that are provided with the source code accompanying this book. So we've run through the whole list. We've printed every single item in that array list out. Let's add a method to iterate over the collection, but only print out those that match a particular search string. So we'll start by taking a copy of the listAllFiles method and pasting it and making a change to the name of the method. We want to call this findFiles. We want a parameter which is of type string, which is going to be our search string. And then instead of always printing out the file name, we want to say only if the file name that we're looking at contains the search string do we wish to print out the name of the file. So that then now should allow us selective processing of the list. So I've just quickly added the files that we had before, and now I can call find all files, and maybe I only want to find all those tracks that contain the word early, and we have just one of the tracks printed out now, which is the only one that contains the word early. So I noted earlier that it's important not to become so focused on the for each loop that we think of using it every time we need to perform some sort of iteration. It certainly has some pros. A for each loop is generally easy to write. Termination of the iteration, so ensuring that the loop stops, happens quite naturally. It stops when we've exhausted the collection, when we've processed the last item in the collection. It provides what we call definite iteration, or otherwise known as bounded iteration, and the number of iterations is bounded by the size of the list. So those are the pros of a for each loop. However, there are some significant cons, and it's important to bear these in mind whenever we're thinking about whether a for each loop is appropriate for a particular programming situation. So it's important to appreciate that we cannot use a for each loop when we wish to change the contents of the collection that is being iterated over. So we're not allowed either to add new elements to the collection during the iteration, or probably more importantly, to remove items from the collection while we're iterating. So for instance, if we wish to remove all of the tracks that included the word early within the collection, we would not be allowed to use a for each loop, because as soon as we tried to remove a particular track that matches that string, then the program would crash. The runtime system would detect that we're trying to modify a collection inside a for each loop, and that's not permitted. Now the compiler won't object. Our source code will still compile and run but it will fail at the point where we try to remove an item from the collection. Another con with a for each loop is that once we've started iterating over the collection, we can't stop part way through. So for instance, suppose we were searching through a collection to see whether a particular track is stored in there, and we find that track, we're committed now to continuing on through the rest of the collection, even though we probably don't need to, because we've established whether the track is in there or not. So we can't stop part way through iterating over a collection using a for each loop. And while there are ways around that limitation, they're ways that we prefer not to make use of, because in general they lead to poor coding habits. So we won't be discussing those ideas further. So take care choosing to use a for each loop. Don't choose it simply because it's the kind of loop that you're most familiar with. Make sure that it's appropriate for the task that you're trying to code. So it's maybe worth considering what some of the characteristics of other loops that we will eventually introduce are. So other loops such as a while loop, a do loop, and a for loop, as distinct from a for each loop, they need a little bit more care to write, in particular to ensure that the iteration stops. So a very common problem in programming is that we can end up with what's called an endless loop or an infinite loop. That is a loop that starts but never stops. We don't get that with a for each loop because the loop's number of iterations is bounded by the size of the collection. But we can easily run into an infinite loop if we use one of the other types of loop. So that's something to be aware of. A little bit of care needed to ensure that the loop will terminate. On the other hand, that greater care is needed largely because those other types of loop offer greater flexibility over the kinds of things that we can do inside the loop body. So in particular, they won't prevent you from adding new items into the collection while iterating over it. They won't prevent you from removing items from a collection while iterating over it. And if you realize partway through iterating over a collection that there's no need to visit the rest of the collection, then you can easily stop the iteration. So in general, we have greater flexibility with the other kinds of loops. And we'll introduce probably the most flexible and most important type of loop in a following video, and that's the while loop.